In this example, we are going to find the intersections of two polar equations. The first thing that you should always do is graph them. I recommend graphing them in Desmos because it's a lot easier to see what's going on than it is in a graphing calculator. And then what you should do is go through and mark where they actually intersect. So we have 1, 2, 3 intersections of the purple circle and the black graph. The purple circle is the unit circle, it's r equals 1, and then the pear-shaped looking graph is of r equals 3 minus 4 sine theta. So we are looking for those solutions. They'll be ordered pair solutions of the form r theta. So we're looking for r's and thetas. Okay, so the first thing that we're going to do is find the simultaneous solution. That is solutions that happen. I can't spell simultaneous, so we'll just go with that. That's finding solutions that happen at the same time. So if they happen at the same time, these two equations are equal to one another. So 1 equals 3 minus 4 sine theta. And then we're going to solve for theta. So subtract 3 from both sides, you get negative 2 equals negative 4 sine theta. Divide by negative 4, you get 1/2 then equals sine theta. And then we know that sine is 1/2 at 5 pi over 6, also at pi over 6, which is good because that looks like it to be about where those 2 points are. So what we need to know, because we're asking for ordered pair solutions of the form r theta, well, both of these are the thetas, pi over 6 and 5 pi over 6. So we need to know what the r's are that go with them. Well, we're saying that r equals 1, so that's what we have here in both of these. If we didn't know that, or if that wasn't given to us, what we would do is you would come over to the side somewhere, do 3 minus 4 times the sine of your angle. So 5 pi over 6. 3 minus 4, this is going to be r. Sine 5 pi over 6 is 1/2. 3 minus 4 times 1/2, that would be 3 minus 2, which is 1, and that gives you r. And you would do that with both angles so you're getting the correct r values. Okay, so I'm going to label this one as A and this one as B, and then I'm going to go and put the labels A. That would be out 1, up pi over 6, that's A. Out 1 and up 5 pi over 6, that's B. And the bad news now is that I have this third solution that I have nothing for yet. So that's a non-simultaneous solution. And what that means is that it happens at a different time. It goes a different way to get there. So what we're going to do, what we're going to try, because we were given an r, we're going to let r be the negative of what we were given. So we were given r equals 1. Let's try r equals negative 1 in equation number 2. So we have negative 1 equals 3 minus 4 sine theta. We're going to solve for theta. So subtract 3 from both sides, we get negative 4 equals negative 4 sine theta. Divide by negative 4 on both sides, you get 1 equals sine theta. Where is sine equal to 1 when theta is pi over 2? And then again, that is going to be our ordered pair C. This is our theta. What's our r value? Well, we let r be 1. So, negative 1. So we're going to say r is negative 1. Well, that makes sense. If you come over, we go negative 1 and down 90 degrees. That's where C is. That's good. The problem is that negative 1 does not solve this equation, our equation number 1. This only solves equation 2. So what we want to know is some representative of that point that solves r equals 1. So we know r equals 1. So let me clean some of this up. So if we go out 1, And we need to end up down here. How far around is that? It's 3 pi over 2. So that is the full solution to this problem. You've got two simultaneous solutions, A and B, and then this non-simultaneous solution, C, with a representation for that ordered pair from each that solves each equation. So this guy only solves equation number 2. This guy only solves equation number 1, but they're in the same spot on the graph. And so that's how you do polar solving polar graphs.